Hello everyone, in this video we are going to make a particle system with geometry nodes, and this is really useful especially where we have cause and effect type situations. So for example, in this case a firecracker of one particles going up and then bursting into a large number of particles, or like bubbles in water or sparks. So there are many places you can use this particle system. So first we're going to build a particle system with the effect, and then we're going to extend that for a particle system chain, means you can run many sequential effects. So let's get started. So here is a plane that I'm going to use as our emitter object. So let's rename this as emitter. So this particle system is based on the curves. We're going to instance curves on this surface, and the advantage of this is you can easily define whatever the path you like to follow by these particles. So let's first add the distribute points node, and then we're going to add the instance on a point node, and we're going to instance the curve line. Okay, you can use a different curve for this. This is just for the sake of tutorial, I'm using this curve line. So we have these curves, and let's also align these curves with the normal of the surface, so that we can easily point in a different direction by rotating the surface like this, and also increase the size to a 5. So this size is basically define the total path length of the particle, and we're going to also randomize the scale of these curves. So let's add a frame for this, and this is curves. Now we have these curves, and also we have to realize these instances to make them real splines. So this is the first step, and here you can control basically the density of the particles, is how much you want for your project. Let's add a reroute, and next I'm going to add the trim curve node, and then we need a resample node, and we need only a one count for this, because we want one particle for each spline. And to visualize this, we need instance on a point node, and let's instance a icosphere. Size may be around 0.15. So we have these spheres. Now if we animate this start, we can animate these particles or curve particles, and we don't want to it based on the factor, because if we increase the length of these curves, it's going to affect the speed. So I don't want that. We want the speed should be independent of the path length, so we're going to use this length. So by animating this start, we can animate the particles, but we have to supply this end length. So let's capture this, change this to a spline, add the spline length node, and then plug this into the end. Let me hide the unwanted outputs. So now by animating this start, we can animate these particles. So let's add the map range node, and we want to animate this length from 0 to this max. So let us plug this into the start. Now by animating this vector, we can animate the particles, and for this we're going to use the time or the number of frames. So here if I type 30, so these particles going to take 30 frames to cover their whole this path length. Now the one problem with this factor means by defining based on this frames is that if I add the random value node here and randomize our curve like 0.51. We can see, let me decrease this to around 50. See, all these points are moving with a different speed, so they should move with the same speed unless we provide a different or random speed to each particles. So this is the problem with the number of frames. So to overcome this problem, we're going to use a simple formula which you may remember from your school days. This is speed is equal to distance over time, and because we have this distance which is the path length, and here we can also define the speed, let's say 0.15. now we have the speed and distance, and from this we can calculate the time for each curve. Okay, let's make some room here and let's divide this distance by this speed, and then plug this as our time. Now see all the particles moving at the same speed. You can also use a random speed here, and we will add that functionality to this particle system. Now the first thing we have to do is that these particles starting from this start frame which is 1. So to control this, let's add this math node and change this to subtract, and here we can define our start frame. If I type here suppose 30 and change this to maybe 100, now they will start after the 30th frame. So this is our start frame, and next thing is all these particles starting means all they are starting together from 30 frame. I want that each particle has different start frame, so for that we have to capture the random value on this input. And remember, one thing I would like to mention, this everything is based on spline, so we have to capture everything on a spline domain. Okay, so then subtract this from our time, and let's here if we type 30 means all the particles going to have random value random start between 0 to 30. So now if we play the animation, see they have their own start frame. And one thing we can also add here for the start frame is that we used a random value for the start frame, but we can also define a gap between each particles, a time gap like a 10 frame, 1 frame. So instead of using this random value, so let's add another capture node and change this to an integer. We're going to add here the index node, so we want the index of each spline, and let's also add the switch node so that we can switch between this random start or the gap frame start. Change this to a float, plug this to a false. By default it's going to have random start, and for this we have to just multiply this index by some number. Means if I type here 1, then each particle going to have 1 frame difference. Let's also type here 1. Let me show you. If I type here 10, see each particle has 10 frame difference. If I type here 0.1, they almost start together. 0.5. So now we have this frame gap start or the random start. And now we can also add randomize this speed. Let's capture another random value And we can also plug this, even though it is not required, we can also plug this as our ID for the random this random value. And one thing I would like to add here is that I want only one factor to control this random value instead of this 0 and 1. So to do that, first we have to use this as our max, and then we need a map range node, and we're going to map between this as minimum and max to 0. Means when our factor is 0, we're going to have both minima and maxima same, but as we increase to 1, it's going to have 0 minima and maxima is this one. But basically this is like a percentage. If I type here 0.1 means we have 10% randomness in the speed. So let's plug this into this and then use this as our speed. And now let's increase this speed to randomness to 1. See, they have different speed. So now we have control on the start and also on the speed. Okay, so the next feature I would we can add to this particle system is that we can loop these particles. Okay, as they complete their journey, they should come to their first position. So basically we have to loop this time, where that we can do this with this modulo operation, and for this number we basically need this time, which we get from our speed. And here we can also add a switch node, so we can switch between the loop or a normal motion of the particles. So use this as our this value to map the length. Now see, they are looping. Let me make this 0 and make this random frame. See, all they are looping. Now we have this particle motion. Now we can add our effect time or control for the effects. Means as the particle reach their final destiny, and after that we're going to execute some kind of effect. So to do that, basically we have to add the time for that effect. So let's add a value node. So let's add, suppose we want that effect for 10 frames, and we can also randomize this number of frames for the effect. So then we have to add that frames into the time that we get for each particle, and then we're going to use this as for the module operation. Okay, so now we have added the effect to these particles. If we play this in a loop, we can see that this effect will work. Means particle will stay for 10 frame here, then come into their start position. If I type here means 20, they will stay for 20 frames. Now we have this particle motion as well as the effect. Now I'm going to add a factor for the particle as for the effect, so that we can control the particles, suppose size or rotation or alignment with that factor. So first we have this animated length for the particle, and we're going to also add a factor which is just cut this. Now we have this 0 to 1 factor. So let me show you how it will work. If I directly plug this into the scale, we can see that as the particles start, they have a 0 scale, but as they reach their destiny, they're going to have 1 scale. This is just the simple operation. You can do this with this factor, but there are many things you can control with this factor, like color transitions. Okay, now let's do this for also for the effect. So for the effect we're going to have two factors, two animated factor. One is basically it is time, so we want this our value, and because our effect is starting after the death of the particles, which is this is the minimum value and this is the maximum, so we have this transition or animated time for the effect. And next we're going to have also factor for 0 and 1, so same thing, minima, this will be maxima, and this is the value, and now we have this 0 to 1 factor for the effect. So another thing we have to add is the switch, means right now let me cut this scale. You can see that particle already there, but they should only appear when they get born, and then they should disappear as they die, and same should be true for the effect. So for that we have to add a boolean switch. So first we need greater than node, greater than, so time, because we are subtracting this random start, means pushing that time backward, so this should be greater than 0. Means if I plug this into this instance on point node, we can see this, all these particles born, but as they born they get appear. Now we have to do this for the death, means when the particle die they should disappear. So for that when this time is less than equal to the time of the particle, only then this should be true. Now if we plug this into selection, we can see that they get disappear. So let's add the AND operation. Is we want these two conditions should be true for the particle. Okay, and for the effect, basically when we had not of this, then we're going to have effect, and as the effect completed their time, they also should disappear. So for that we have to use this time, this should be less than, also add the AND operation. Now we have this for the effect. So let me duplicate this and change this to a cone. So let's also join these together. So let's plug this into the selection. So when the particle die, the cone will appear. Let me change this to 0.2. For 20 frames, if I type here 10, then cone will appear for only 10 frame. And here we can also plug this into let's add a map range value node, initial scale 0 and final will be 25. See, their size increase for the 10 frames. So now we have everything. Let's make a group for this. Let's move this outside from this, and now let's make a group. Control G, and one thing I forgot is, let me enable the screencast keys. Okay, and We can also align this particle to the normal or to the tangent of this curve. So we can also capture those here. Change this to a vector, also change this to a vector. Type here normal. So normal of the path on which the particle is moving. Then we have curve tangent. And another thing I would like to add here is that especially this is useful for the loop, like a loop counter. Means for each loop you can use this counter to randomize the size or the direction of other particles. For each loop, particle going to have a different color, size, or any property you would like to change with that. So for that, basically we have to divide this time by this a total time, which is particle plus effect. Then we need floor operation. We don't want this fraction, and this time can be negative because we are subtracting our start. So this should be maxima, means when it is negative, then it should give us 0 value. Now we have almost everything. Now I'm going to rename these all inputs for this particle group. I'm going to fast forward this section of the video. Okay. Now we have this finalized group with all these proper naming of the inputs and the outputs. So now let's here type speed 0.1, seed 0, random factor 0, frame k, then range 30 frame we want in a loop, and vector for 10 frames. Now select connect this to this selection. Now we have this particle system. Okay, so here you can use this vector to control the basically scale of the effect, or use this vector where it is, yeah, here it is, for the particles. Okay, now this is the particle system with the effect. Now we're going to extend this for the particle system chain. So now we're going to extend this for this group for the particle system chain. let's first rename this as chain, and in the chain we don't going to need this effect section. Okay, and also we have to remove the loop, and it is possible to do this for the loop. That will complicate a lot, and I'm going to keep this simple. So let's remove the effect section here, and also remove the loop, and also delete the unwanted outputs, like we don't need a loop counter. Also we don't need these things. We have a particle system without the effect section, and to connect this in a series or in a chain, first we have to add the switch node here. So we want to switch between the time, means if this is a first group of the chain, then it is going to use this time. Otherwise it's going to use the time which will come after this group. Let me delete all these things. Means when we're going to connect them in a chain, then we're going to use evaluate time of this group as input for this group. Let's output this. This will be the switch, and this is the time from the previous group. And another thing we have to do is that we have to also output the time from this group. That will be, we have to subtract the time which is taken by this the particles of this group, which will be this time that we have calculated from the speed. And we can also add the switch node for the chain system. Is, let's duplicate this, or just add a node here, that will be switch for the chain. So now let's output this and this. So let's change the name. This is use chain time, and for the output this is chain switch and then chain time. Now we can connect these group in a chain. So first to connect them in a chain, we have to add the curves, because for the first group we have these input curves. So for this group we have to create the curves. Let's instance the curves at the end of the curves for this group. So let's add the C line, and let me show you what it is doing. So we have the curve lines at the points of this curve, but we only want at the end. So let's add the end selection node, plug this into this. Let's also align them to the normal so that we can see the difference. Now see, okay, these curves are these curves are pointing this way, and these curves are pointing in this direction. Next we have to realize them and then connect them to this curve. Okay, now let's also duplicate this section. So let's instance the difference. Let's add cube, maybe size around 0.25, and also connect this to this selection, and also join to the geometry. And now let's plug this chain time into this and enable the chain. And one thing I would like to mention is that as soon as you're going to use the chain time, it will ignore the start and as well as the random start for the second group. Now see, particles go up, then they converted into cubes and then goes in this direction, and we can repeat this step even for the third time. Let's duplicate this. Now let's see, icospheres, cubes, then converted into cones. Okay, with this particle system you can animate this point, but you can also animate the curve which we have used as input for the points. So this is exactly what I did for this firecracker example. So this is it, and you can download all these project files and these finished preset for the particle system and particle system chain from my Patreon page. If you like this work, then please do support me and subscribe to my channel for more updates. Until next time, happy noding. Bye.